Good morning, everybody. Thank you very much for gathering today. My name is Jun Koketsu. I'm a product planner for our newly developed EV vehicle called AFEELA. So today we wanted to cover some of the aspects in terms of UI and UX of this new product, especially around the visualization of 3D maps, system UI, and also the ADAS sensing view. And particularly, we're going to dive into the native map rendering system that has been newly released for the UE 5.6. So just kind of, as an introduction, we'd like to start off with the overview of our company and our product. So we are Sony Honda Mobility. So we're 50-50 joint venture between Sony and Honda. And we're planning to develop and release the electric vehicle called AFEELA 1, planned for the delivery of middle of 26, which means next year. Okay. So again, hello everybody. But as you can see, we have this external information displays called media bar. And this might look kind of funny, but the point is what we want to aim is that we want to redefine the relationship between people and mobility. Until now, it's like, if you think about vehicle, it's like you really kind of direct or command the vehicles to do what you want them to do, like, brake, hit the brakes, or, steer. But what we want to do is like having all those essence of sensing and AI technologies. Now the vehicle itself will understand the intention of the user, of the driver, and provides a proactive feedback. That is the future of mobility that we want to accomplish. And in order to realize that, we have a concept called 3A concept: autonomy, augmentation, and affinity. So autonomy, of course, the safety is the utmost importance for mobility experience. So we're going to provide the cutting-edge ADAS functionality supported by 40 sensors inside and outside the vehicle, together with 800 TOPS of processing power. And on that foundation of safety, the augmentation, meaning that in-cabin is going to be a place where user will be able to really sit back, relax, and enjoy all the entertainment content. And here, what we want to do is that we want to blur the borderline between reality and the virtual. And I'll get into that later. But in order to realize this vision, we cannot do it by ourselves. So affinity, meaning that coexisting or collaboration with partners and society is very important. So those are the 3A's that kind of explain about our concept here. And just going back to our brand name, AFEELA, it might sound new to you, but what this is that in the middle we have feeling, meaning that we want to provide the kind of a relationship between the vehicle and the users. It's more like a two-way communications. And that is going to be accomplished by having the autonomy, A, and the augmentations. And in order to realize that, of course, the affinity encompasses around this branding. So this is the name, the kind of logic behind our name here. So mobility as a creative entertainment space. So with the ADAS, what we want is that we want to really minimize the burden of the drivers really driving, but still be able to go to wherever they want to go. So it is more like a kind of a third place for the users to really enjoy the entertainment content. And we have that aspect from the visual and audio experience perspective. So for the visualizations, as you can see, we have like sensing data or the map data, but it's very important how we visualize those data so that user will be intuitively able to understand and figure out what is happening around him or her. So, but as you can see on the left-hand side, or on the front of the steering wheel, that's a cluster, and that shows the feedback of the sensing data. And for the map, we fully utilize our panoramic screen. And it's not just the tools to go from A to B. It's more like, it's beyond the tools, meaning that map itself could be entertainment content that is tailored for the mobility experience here. And here we have fully utilized and worked together with Epic Games members and make it fun and exciting. So if you look into the in-cabin design, here's a design concept, but we have an array of displays, also coupled with the digital mirrors on the side. And the yoke steering will provide more visibility for the screens itself. But the point here is that the driver or the user's, passengers' iPhone just goes on the sideways, and all the information could be captured. So without having the vertical movement here. And as I mentioned, this is like a third place on the go. So it means that we want to really customize the in-cabin to those people's liking here. So with the screens and also the ambient lightings, users will be able to really personalize the in-cabin atmosphere here. And of course, for the entertainment content, we have worked together with various music or movie service providers. So ranging from movies, music, podcast, karaoke, and of course the PlayStation gaming you can play on our car here. And together with the visuals, of course, sound means a lot to really maximize the entertainment experience here. So we have Sony, so we have worked with Sony audio team to make sure that we have the best sound experience here, and we support Dolby Atmos and also spatial sound systems, together with very, very high quality sound field tuning here. And this is for the entertainment content, but we wanted to do something that is also tailored for the mobility experience itself. So we have this e-motor sound. And e-motor sound also could be not just one, but there could be many variations. We're actually working with sound creators to make variety of e-motor sound here. So it's like focus, and you can also have like relax. So depending on the user's mood, user will be able to change the e-motor sound as they want. And we have this program called co-creation program in order to make have many e-motor sound into our vehicles here. So that was kind of the overview of our product. But now we'd like to dive into the technical details on how we realize this experience together with Epic Games and Q Games member. So I'd like to invite Takuya Nishibayashi here. But thank you very much.
Hello, my name is Takuya Nishibayashi. Please call me Tak for short. So I'm a general manager of A&D system architecture for AFEELA product. So from now on, I would like to take over this, this session from June. Then, so until now, so he just mentioned our company concept and the car concept. But probably I think all of you guys want to know, so what kind of technology will be used for our AFEELA one? Then, today, I would like to show these three keywords. So now we are thinking to put this real and virtual. It means we strongly would like to make a kind of a bridge between real world and the virtual world. But to realize that, as you know, we needed to have three technology keywords. So one is data. Second one is sensing. Third one must be 3D graphics. Then, to bridging real world and virtual world, today we have 40 sensors for our AFEELA 1 near production model. But only sensor cannot understand what kind of things is going on around the car or inside the car. Then, for that, we are thinking to provide enough computing power and low consumption and telecommunication functionality is needed for developers. Then, we are now using Qualcomm Snapdragon Automotive series for our key ECUs. At this moment, today, I cannot tell very detailed things of each ECU though. But as you can see, we have ADECU, autonomous driving ECU, then telecommunication ECU, and UX and HMI ECU. So today, we have a capability for autonomous driving with 800 TOPS calculation power for AI. On the other hand, today, we strongly would like to emphasize, what kind of user interface and user experience will be realized. For that, we have two dedicated ECU. One is, again, named HMI ECU. Another is UX ECU. But later, one of SHM engineer will explain our system architecture detail. But today, at this moment, I would like to emphasize each main ECU is connected by gigabit Ethernet. Then, from software point of view, ECU is no more standalone computer. Then, why with Unreal Engine? As per Jun mentioned, we strongly would like to realize bridging real world and virtual world. For that, we need to have very high capability rendering, user interface rendering engine. So this is Unreal Engine from our point of view. So then, you can see this is rendered by our HMI ECU. This is kind of a sphere and 3D map and kind of a 3D environment surrounded the car. So at this moment, this is definitely prototype. So I cannot say this will be launched, but this is our target. We definitely want to bring our AFEELA prototype and ECUs, but unfortunately today we cannot prepare. Then from now on, our engineering team will explain by using PowerPoint and personal computer to demonstrate how to use Unreal Engine map native rendering system. But this is kind of evidence. This is not, how can I say, only on paper or PowerPoint. So this is now actually working on HMI ECU. But I strongly would like to emphasize this is prototype for both hardware and software. So finally, we will start more technical session that you have been waiting for. Then, I will invite 3 engineers from Epic Games, Q Games, and SHM. SHM stands for Sony Honda Mobility. So Q Games is our first-party partner. So, even though Sony and Honda, we don't have much capability for how to realize real world by using Unreal Engine. Then, this is the reason we decided to work with a gaming company in Kyoto, Japan. And finally, SHM members. Okay, then at first, we would like to invite Joe at Epic Games. Joe, please come to on stage.
Thank you, Tak. Hey, everybody. So I'm going to give a quick recap and update on the work my team has been doing getting our HMI map rendering ready for release. So just to do a recap, we announced our stylized HMI map rendering for Unreal Engine at last UE Fest in October. And there are 3 pillars of our development for this feature. Firstly, we want it to be highly flexible. Current map systems in cars today are very restrictive about what you can do in terms of compositing with the UI, in terms of control, what gets displayed, and really it limits the types of experiences that can be developed, especially as we approach autonomous driving, where it's more than just getting from point A to point B. Maybe you want to explore a certain area or have different kind of experiences. Turnkey, so we want to be able to easily drag and drop a map into an Unreal scene. HMIs are complex with many different components, and being able to have the map inside the Unreal scene very easily makes it really easy to work with. And then engaging experiences. So we would like to be able to allow passengers to have really engaging experiences with the map scene, bringing new ways of interaction with the map. And so these are some of the pictures that we revealed at the last UE Fest. This is downtown Detroit. You can see we have native vector rendering with 3D generated buildings, and those vector rendered roads are piped into a material, which then allows further customization. And then here's an image of Seattle. And so what we've been up to recently, I'll play a video here for you. So this is a fly-through of New York City and Lower Manhattan, starting with a night style. And then we seamlessly transition to a day style. And then next, we're going to kind of show you the different features of the mobile renderer that we use to get the day style look. And of course, we support many different kinds of styles. So here we have a VFD style, and then kind of a glass style for the buildings. And all of these different things together provide really powerful styling to create new ways of engaging people with the world around them. And so I like to describe it as a map rendering canvas that allows creators to create new navigation, exploration, and guidance experiences for their customers. And so the things that we're working on this year to get this ready, we have our Unreal powered styling. You just saw the many different ways that the map can be visualized, and we're really excited to see what types of designs and stuff people can come up with. And then, of course, production readiness. So there are a lot of subsystems that work together here to provide live map data rendering like this. And so we're hard at work making sure that all of those subsystems are capable and production ready to run on the mobile hardware. So next, I would like to invite Q Games and Pierre up to show a little bit of the work that Q Games has been doing.
Yep. Thank you, Joe. Thank you, Joe. Thank you very much. So I'm Pierre. I'm a gameplay programmer at Q Games, a company based in Kyoto. And so as you have seen, we have, on one hand, we have this very intelligent car with a lot of sensors, and on the, should I skip? Okay. And on the other hand, we have this very nice rendering map. So for Unreal Fest, we've decided to come up with a little tech demo that's gonna blend the two things together. And Unreal Engine is the perfect place for this because it allows us to create informative and entertaining experiences with very easy to use tools. So tech demo. Here we go. So this is the AFEELA inside the engine in all its glory. Let's press play. Here we go. So now you can see the map being rendered live, the AFEELA being positioned correctly in the map, and all the entities being detected by the sensors, more specifically the ADAS. This is a place near the convention center, actually, with a nice crossroads, so you can see a lot of entities. Here you go. So, how do we render the map inside the engine? It's very easy to use, actually. We have this blueprint here called Tile Manager. It's just a drag and drop, and the map is being rendered. Also, we have this very useful data asset called vector data asset, which is here. That allows us to control the different colors of various things inside the map. So, for example, for construction road, we can change the color right here, or we can also play with the thickness of each road. It's that easy to use. So in this tech demo, it's a little bit tricky because we have 3 coordinate systems at play. So of course, the AFEELA is driving in real world, so it needs to rely on GPS coordinates. Then we need to put these GPS coordinates inside the engine for the AFEELA to be at the correct position. And then all the entities being detected by the ADAS are actually in AFEELA coordinate space, local space, as we can say. So how do we do that? So first, the AFEELA car. So we have this class, the AFEELA GPS handler. We can simply subscribe to this event, update AFEELA car, and this already gives us in-engine location. We don't have to do anything else. It's already ready to use. We also have the heading of the car right here. And then we just set the actor location, and voila. It's that simple. Then we have to move, once we have our AFEELA car, we need to render other entities. So for this, we've created this simple blueprint called ADAS Manager. Again, we have this class, AFEELA ADAS Handler, where we can subscribe to this simple event right here. And this, every frame is going to give us all the entities being detected by the sensors. So here you have like a little snapshot, a little example of what you can get inside this data. So in this struct, we have the position in the local coordinates. We also have the bounding box, which is like the scale of the entity. Its heading, again, it's in local coordinates, and the type. So we currently support different type, car, pedestrians, bicycle, etc. And here is the most important variable of this structure. So you see, this is a feature unique to the AFEELA. Each entity that is being detected is assigned an ID. And this ID is unique to each entity, of course. This allows us to have permanence between the objects. So once you detect this car, it's going to stay the same car, even though the event is being refreshed. So this allows us to animate a certain object a certain way, interact with it as well. And this is really great for us as gameplay programmers. And yeah, so ADAS Manager is basically a simple pull system. We pull, we releases, and of course we update. So when we need to pull an object, we assign its ID, which is very important again, and voila. Now let's see how we actually position the ADAS cars, so the entities being detected by the ADAS, inside the engine. So as you can see, so the data we just saw are being passed with the position, the bounding box, the heading as well. So what we do here is very simple. We use the same world location and world yaw given by the AFEELA GPS handler, which is the AFEELA car transform, basically. And then we simply add these to, from these position, we add the entity's position, make a nice little transform, and voila, our car are being rendered at the correct position. So this is how at QGames we're allowed to create experiences like this that helps blending the physical world and the virtual world together. We've also created the same thing on the left picture. So this is the main dashboard of the car. It's somewhat similar, but you have also various information about speed or remaining battery. So not only the ADAS car has external sensors, there's also internal sensors as well. So on the top right image, you can see our cute little mascot we've created. It's called Doratomo. And so Doratomo is animated based on users' interaction. So for example, when the car drives, it's going to flip around and run on the treadmill. Or if a passenger leaves the car, it's going to wave to say like, bye-bye. So that's it. That's it for QGames. And now I will invite on stage Yamaguchi-san, which is responsible for data flow and system architecture. Thank you.
Okay. Thank you for inviting me, Pierre. I'm Yuya Yamaguchi. I'm software engineer from Sony Honda Mobility. From me, I will explain our data flow and architecture of our platform. Data flow between ECUs. AFEELA has a wideband Ethernet, allows it to send information such as sensor data and perceived obstacles and directly to the IVI. These data can be utilized not only for the vehicle control, but also for the infotainment and entertainment for the IVI. These data are transmitted over the 1 Gbps Ethernet, and it can be dynamically controlled by software. The camera has dedicated line of 10 Gbps, allowing for the transmission of multiple camera data in an uncompressed format. I will explain how these data can be utilized and displayed in the following slide. The AFEELA platform is through collaboration with various partners. First, SHM is developing a platform that supplies the sensor data and map data as previously mentioned. Next, Epic Game is developing a core plugin for map rendering, considering support for various map providers. This collaboration made it possible to support AFEELA. Finally, QGames is developing a 3D application utilizing these data and plugins with Unreal Engine. The AFEELA platform is characterized by its ability to aggregate these data into the Unreal Engine and utilize Unreal Engine's rich framework for representation. This time, what I want to emphasize is that it has become possible to recreate the 3D world using Unreal Engine. The Unreal Compass plugin can import map data. The plugin can import map data hierarchically, allowing for the data to be imported in a way that is optimal for mobile. As a specific data flow, the view changes based on the user tap actions in application and the movement of the vehicle itself. The Compass plugin dynamically selects the tile data based on that information that should be displayed, taking the FLASM into account. Based on this information, tile requests are made. Tile requests are made through the API of spatial mapped data service client. But the API is adjusted to enable more efficient and optimized data retrieval. The data obtained through the tile request is a form of metadata, and it is converted into the tile data containing a 3D mesh structure through tile conversion process. Ultimately, this data will be styled in Unreal Engine and displayed as more impressive objects. It has also become possible to handle sensing data and perceived data from the real world. These data are time synchronized and managed in a coordinate system similar to that used in robotics. These mechanisms allow for the easy integration of perceived data obtained from multiple sensors. In addition, existing big control information and warning information is also transmitted temporarily and spatially correlated manner. By integrating these data, it is possible to represent dynamic or changing living world in Unreal Engine. Our architecture is also designed to handle these elements in a consistent manner. By extracting 3D features from each of these data and performing matching, it is possible to achieve a high precision in alignment. The matching process corrects a big position, enabling sensing data to be correctly displayed on the map. This allows for the projection of dynamically changing living information onto the replicated 3D world. This is the conclusion of our architecture. We are developing a platform that can handle sensor data and map data with a consistent manner. These can be handled on Unreal Engine, allowing for the flexible customization of expression. AFEELA is a UX platform for new mobility entertainment. Additionally, like the concept of AFEELA, we aim to create a platform where as many creators and engineers as possible can collaborate. Thank you. That's all from my side. Thank you.
So actually, that was the end of our presentation. Did you like it? Good? Yes. Thank you.